Hello friends, I Prof.Darshan Thakur from Terna Engineering College Dharashiv welcomes you on my YouTube channel for this subject head Control System Engineering. So friends, as far as our today's session is concerned, so we will try to learn this technique whose name is nothing but what? The polar plot presentation. So one basic question arises in our mind key why we are plotting or why to sketch such type of polar plot. So basically, first of all, we need to understand this polar plot is nothing but what? It is the curve or it is the graph in between the magnitude and the phase angle of given open loop transfer function of any control system. Means by tabulating these two important factors of this control system, which are nothing but what? The magnitude and phase angle for the different values of frequency, definitely we too can determine the overall stability of that control system. And see, that is the basic objective behind this polar plot technique. So we need to understand key by the virtue of magnitude and the phase angle for given open loop transfer function, we do can determine the overall stability of that control system. So as you can see, with the help of this objective, what we need to do here, the objective is nothing but what? Or in any kind of university question paper, the objective will be like this: is sketch the polar plot for following unity gain control system whose open loop transfer function is denoted by this statement, that is nothing but what? G of s equals to 10 upon s into s plus 1 times of s plus 2, and also determine the overall stability of that system. So such type of objective we used to have with us whenever it is required for we people to plot the polar plot for given feedback control system or for given unity gain feedback control system. So first of all, we need to understand the design procedure for this polar plot. So in the design step number 1, once it is clear that this this polar plot is nothing but the curve in between magnitude and phase angle for given open loop transfer function. So we are supposed to tabulate these two factors of this open loop transfer function for the different range of frequency. So what we need to do, first of all, we need to replace or we need to convert this open loop transfer function in case of frequency domain representation. So for that purpose, wherever we used to have this term called it as S is being replaced with this j omega. So our open loop transfer function will become g of j omega equals to 10 upon j omega into j omega plus 1 followed by j omega plus 2. So this is how our open loop transfer function will look like in terms of frequency domain representation, right? Once it is being replaced in case of this frequency domain representation, the next thing here which we need to do key, we need to observe how many number of factors we used to have in that open loop transfer function. Factors in the sense how many constant terms, how many zeros and how many poles we used to have in this open loop transfer function, that we need to define, right? So how to get the number of zeros, as we are very much aware of this thing key, we are supposed to equate all the s terms belongs to this numerator of this open loop transfer function equals to 0. Then we will come to know that there are how many zeros. In same manner, we need to equate each and every s terms which is being located within this denominator with respect to 0 to define how many number of frequencies we are having with us that can be categorized as a poles, right? So initially we don't have any s terms at this numerator, so we don't have any 0, we are having one constant term, and as far as its denominator is concerned, so within that denominator there are 3 identical terms. Those are nothing but what? In terms of standard time constant form, it is 1 over s into s plus 1 times of s plus 2, right? Once these are being replaced in case of this frequency domain representation, so it will become 1 over j omega times of j omega plus 1 times of j omega plus 2. So there are 3 poles, means what? The order of that system is 3. Here we need to define what type of system and the order of that system. As I told you earlier, the order of that system is 3. Then after that we need to define the type of that system, right? So in order to decide the type of that system, quickly we need to look around at that open loop transfer function. Here how many number of poles we are having with us which are present at that origin, right? So as you can see, there is only one pole which is present at that origin, that is nothing but what? 1 over s or 1 upon j omega. So the type of that system is nothing but what? 1. So it is a type 1 order 3 system which consists of 3 poles and 1 constant term. We don't have any 0, right? Then after that what we need to do? Then as I told you earlier, it is the plot in between this magnitude and phase angle. So in that next step, this will be step number 1. So in that next step we need to define the magnitude as well as the phase angle of this open loop transfer function, right? Now let us consider, if suppose such type of reference signal we are having with us R equals to A plus IB, right? So as we know, it consists of this real as well as imaginary part. So if we are interested to define the modulus or the magnitude of this reference signal, so how to decide the magnitude, which exactly equals to square root of its real part square plus imaginary part. So it will become a square plus b square. In same manner, if we are interested to define the phase angle for this reference a signal, so it will be tan inverse of b by a, right? Where b is nothing but what? Imaginary part, and a is nothing but what? The real part. We need to understand key how to determine the modulus as well as phase angle for this given open loop transfer function. So initially we will try to tabulate the magnitude of this open loop transfer function. So here within its numerator we used to have only one single constant term. To this constant term we don't have any imaginary parts. Its real part is nothing but what? 10. According to this basic definition, its magnitude will become what? Square root of real part square plus imaginary part square. So square root of a square means what? 100. So again the square root of 100 is again 10. So it will become 10. As far as its denominator is concerned, so the first term is nothing but what? It is j omega. Its imaginary part is nothing but what? Omega. So according to this definition, magnitude equals to square root of a square plus b square. If you are interested to determine the magnitude of this 1 upon omega, so it will become 0 square plus omega square, and the square root of omega is nothing but what again? It become omega, right? So the magnitude for this 1 over j omega will become omega. Similarly, the next term is nothing but what? J omega plus 1. Its real part is 1, imaginary part is omega, square root of real part plus imaginary part. So it will become square root of 1 plus omega square. The third term is nothing but what? J omega plus 2. Its real part is 2. So 4 plus omega square, right? So this whole statement will be the magnitude of this open loop transfer function. In same manner, we need to define this term that can be called it as a phase angle. So here I will write, denoted by this phi, the phase angle of this g of j omega. Again, g of j omega is nothing but 10 upon j omega times of j omega plus 1 into j omega plus 2, right? So as far as this constant term is concerned, so always the phase angle for this constant term is 0 degree, right? As far as the denominator is concerned, so the first term is nothing but what? 1 upon j omega. How this phase angle is to be tabulated? With the help of this trigonometric function tan inverse of its imaginary upon real part, right? So we don't have any real part in this expression, so it will become tan inverse of real part is 0 and its imaginary part is what? Omega. Sorry, tan inverse of imaginary plus real. Tan inverse of omega by 0, where omega is nothing but what? Its real part. As far as the second factor is concerned, that is nothing but j omega plus 1. So its phase angle will become tan inverse of b by a. Its real part is nothing but what? 1, and imaginary part is nothing but omega. So tan inverse of omega by 1. Third factor is nothing but what? 1 upon j omega plus 2. Its real part is 2 and imaginary part is j omega. So it will become real, imaginary upon real, omega by 2. So this is how our statement will look like, right? Now we don't have any phase angle belongs to this numerator. Within this denominator we are having 3 trigonometric function in terms of tan inverse. Tan inverse of omega by 0, tan inverse of omega by 1, tan inverse of omega by 2. As these 3 terms are being shifted to this numerator, so that can be rewritten as a, see here, tan inverse of omega by 0 means infinity. So when this tan inverse infinity is being shifted to the numerator side, it will become minus tan inverse of infinity minus tan inverse of omega minus tan inverse of omega by 2. So basically so friends, the phase angle statement will become what? As these 3 terms are being shifted to the numerator, as a result of shifting it will become tan inverse of omega by 0, something divided by 0, obviously it will become infinity. So it will become minus tan inverse of infinity minus tan inverse of omega as it is minus tan inverse of omega by 2. So our phase angle will become what? Here I will write. So phase angle of this g of j omega will become tan inverse of infinity means 90 degree. So minus 90 minus tan inverse of omega minus tan inverse of omega by 2. So this is how the phase angle of this open loop transfer function and the magnitude of this open loop transfer function is being declared, right? As I told you earlier, polar plot is nothing but what? The way in which we are plotting these 2 parameters with each other for different values of this omega, means this omega is being varied from 0 to infinity, right? So what we need to do now, for these 2 different intervals, we need to determine the magnitude as well as phase angle. Which 2 intervals? When omega equals to 0 and when omega equals to infinity. So initially what we need to do, we need to substitute this omega tends to 0 and this omega tends to infinity with the help of this limit statement in order to decide the magnitude and the phase angle of this open loop transfer function. So let us quickly go through the magnitude of this open loop transfer function equals to when, here I will write, with the help of this limit statement, when omega tends to 0, at that time the magnitude of this g of j omega equals to what? So in this expression what we need to do, we need to replace this omega with this 0th value. So it will become 10 upon, when this omega is being replaced as a 0, so 10 by 0, 0 multiplied by anything 0, so 10 by 0 the magnitude will become infinite, right? When omega equals to 0, according to the basic definition of this magnitude, it becomes infinite. At the same time, we need to determine the desired phase angle of that given control system by putting this omega equals to 0. So here I will write the phase angle of this g of j omega equals to, when omega is being equated as a 0, so minus 90 degree minus tan inverse of omega equals to 0. So tan inverse of 0 is 0. Again 0 by 2, obviously 0. So here the desired phase angle for this given control system is how much here? Minus 90 minus 0 minus 0, so minus of 90 degree. Right. This will be the magnitude and the phase angle for this given unity gain feedback control system where omega equals to 0. Then in that second interval, what we need to do again, with the help of this limit statement, omega tends to 0. By putting this omega equals to infinity, one more time we need to determine the magnitude of this g of j omega and the phase angle of this g of j omega. Right. Similar to that first case in which or where this omega, it was replaced with this 0th value. Now it's time to replace this omega with this infinite value, right? So here the magnitude will become what here? 10 upon omega is being replaced with this infinite value. So 10 by infinity, obviously something divided by infinity, it equals to what? 0. So here I will write 0. At the same time, what will be the phase angle for this given control system when omega tends to infinity, right? So according to the definition of this phase angle, it equals to minus 90 degree minus tan inverse of omega minus tan inverse of omega by 2. So it will become minus 90 degree minus tan inverse of omega is being replaced with this infinity, again minus tan inverse of infinity divided by 2, right? So as we know, this tan inverse of infinity is 90 degree, tan inverse of infinity is 90 degree. So in case of this second case, when omega equals to infinity, its phase angle equals to minus 270 degree. Now once we are having the desired value of the magnitude and gain for these two intervals, when omega equals to 0 and when omega equals to infinity, after that definitely we can plot the sketch for this polar plot, right? So this is how these 4 coordinates will look like. This will be the imaginary and this will be the real axis, right? So here one thing which we need to understand key, after declaration of this magnitude and phase angle, we are coming on to this conclusion key, this polar plot, right? This polar plot will try to touch this minus 90 degree line at infinite value when omega equals to 0, and at the same time this polar plot will try to touch this minus 270 degree line, right, when omega equals to 0. At this 0th value of omega, this polar plot will try to touch this minus 270 degree line. So we need to understand at what point this minus 90 degree and minus 270 degree, these two lines are being located in this coordinate system, right? As far as these 4 coordinates are concerned, if we follow the anti-clockwise direction, if we go in this direction, so this will be the 90 degree line, right? Again this will be the 180 degree line, this will be 270 degree line, and this will be the 360 degree line, right? But we want the minus 90 degree and minus 270 degree, right? So in order to have these two relevant phase angles, we need to follow the clockwise direction. If we go in this clockwise direction, so here this will be the minus 90 degree line, right? This will be minus 180 degree line, and this plus 90, or this will be the minus 270 degree line, right? Now according to the tabulated value, as I told you earlier, this polar plot will try to touch, right, this open loop transfer function whose magnitude is nothing but what? When omega equals to 0, it will have the infinite value of magnitude, and at this infinite value it will try to touch this minus 90 degree line, right? So where we are having this minus 90 degree line, at this point we used to have this minus 90 degree line. Here I will write, this will be the minus 90 degree line, but we cannot predict the intersection point of this polar plot with this minus 90 degree line, because that can have the infinite value. But as we know, this is the type 1 order 3 system, so obviously the polar plot will exist to the left hand portion of this real and imaginary axis. So if we consider at this point, right, at this point this polar plot will try to touch this minus 90 degree line, and it will go towards the origin like this. So this will be the direction of plot, right, for this first value. In that remaining half, when omega equals to infinity, right, its magnitude will become 0, and at this moment this polar plot will try to touch this minus 270 degree line when omega equals to 0, right? So this is how your polar plot will look like, right? When omega equals to infinity, at that time it will try to touch this minus 270 degree line for the 0th value of this omega, means at that origin. So this is how your polar plot will look like. So this is the half part of this example. In this part we have tabulated the magnitude and the phase angle for this given open loop transfer function. Once these two parameters are being tabulated, we need to iterate this omega from 0 to infinity, and for these two iterations its magnitude and phase angle we need to tabulate. Once this magnitude and phase angle is being tabulated, then after that we can draw the relevant polar plot of this given control system, that is nothing but what? The curve in between the magnitude and phase angle. As we know here, when omega equals to 0, the phase angle is how much? Minus 90 degree. That can be treated as a phi 1. And when omega equals to infinity, the phase angle equals to phi 2, right? So in that remaining part, what we need to do, we need to comment on the overall stability of this control system, right? So for that purpose, we need to determine its gain margin in terms of decimal, right? So in order to decide this gain margin, we are in need of this total phase rotation taken by this polar plot, which exactly equals to what? The phase rotation PR equals to phi 2 minus of phi 1. Here phi 2 equals to minus 270 degree and phi 1 equals to minus 90 degrees. So minus minus it will become plus. So phase rotation equals to minus 180 degree. Okay friends, so after sketching the desired polar plot for given unity gain feedback system, the next thing which we need to do we need to decide the overall stability of this system with the help of this gain margin, right? So in order to decide the overall stability of that system, this gain margin is to be tabulated with the help of this omega PC, that is nothing but the phase crossover frequency, right? Because this gain margin is nothing but what? That can be treated as, this will be the reciprocal of its magnitude. The modulus of G of J omega is nothing but what? The gain margin, right? So in order to decide this gain margin, first of all we need to tabulate the phase crossover frequency, right? Now this polar plot is nothing but what? The plot in between magnitude and phase angle, right? Its phase angle statement is nothing but what? G of J omega equals to minus 90 minus tan inverse of omega minus tan inverse of omega by 2, right? If suppose we are marking this statement as a equation number 1, right? So from this equation number 1, what we need to do, we need to decide its gain margin. So the first step towards this gain margin is to, what we need to do, this phase rotation is being already tabulated. Phase rotation for this polar plot is nothing but what? Phi 2 minus of phi 1, where phi 2 is how much? Minus 270 degree, and minus phi 1 is 90 degree, so plus 90 degree. So the total phase rotation taken by this polar plot equals to minus 180 degree. So we need to equate this minus 180 degree as a desired phase angle, and the statement is like this: minus 90 minus this omega is being replaced with this omega PC, phase crossover frequency, minus tan inverse of omega PC minus tan inverse of omega PC by 2, right? So in that step, what kind of procedure we need to follow here? This whole statement is being derived or is being declared in order to determine the phase angle of that unity gain feedback system. Okay friends, so once the polar plot is being sketched, then after that the total phase rotation taken by that polar plot is exactly equals to minus 180 degrees. So that same value is to be substituted within this equation number 1. Equation number 1 shows that the way in which we are supposed to tabulate the phase angle for this given unity gain feedback system, which exactly equals to minus 90 minus tan inverse of omega minus tan inverse of omega by 2, because in that lateral part we need to decide the overall stability of that system with the help of this term that can be called as a gain margin, right? So this gain margin is exclusively depends upon this frequency, whose name is nothing but what? The phase crossover frequency denoted by omega PC, right? So what we need to do now in that next step, as far as this equation number 1 is concerned, so as we know, the total phase rotation taken by that curve is minus 180 degrees. So phase angle equals to minus 180. Then the term which are being written to the right hand side of this assignment operator, minus 90 minus tan inverse of omega is being replaced with this omega PC. So as a result of this, it will become tan inverse of omega PC by 2, right? Then after that, simple mathematical simplification we need to do. This minus 90 is being shifted to the left hand side of this assignment operator. As a result of shifting, this minus 90 will become plus 90, minus 180 plus 90, remaining term is minus 90 equals to tan inverse of omega PC minus tan inverse of omega PC by 2, right? Somehow we need to put this whole term in case of this tan inverse of A plus tan inverse of B, because tan inverse of A plus tan inverse of B equals to tan inverse of A plus B upon 1 minus of A into B. In that form we need to put this term. So for that purpose, see, if you multiply both these two terms with this negative sign, so it will become plus 90 equals to tan inverse of omega PC plus tan inverse of omega PC by 2, right? Now as you can see, this term is existing in terms of tan inverse of A plus tan inverse of B. So we need to use this half angle formula. As a result of this, it will become 90 degree equals to tan inverse of omega PC plus omega PC by 2 divided by 1 minus omega PC into omega PC by 2. Then furtherly simplification will be what? This tan is being shifted to the left hand side of this assignment operator. As a result of shifting, it will become tan 90 equals to remaining term as it is omega PC plus omega PC by 2. Its denominator will become what? 2 minus omega square PC divided by 2, right? this 2 minus omega pc into omega pc, omega square pc by 2. So as we know, tan 90 equals to what? Tan 90 equals to infinity, right? And this according to this trigonometric function, tan 90 equals to infinity. So infinity is nothing but what? If suppose we are writing like this, tan of 1 by 0, right? So obviously tan of 1 by 0 equals to what? Infinity. So tan 90 is nothing but what? Infinity. So if we replace this tan 90 with this tan of 1 by 0, right? So by doing this cross multiplication, this whole term will get multiplied with this 0, and this denominator will multiply with this one. So as a result of this here I will write 2 minus omega square pc by 2 equals to 0. So omega pc equals to root 2. The phase crossover frequency equals to how much here? Root 2. Okay friends, so once the phase crossover frequency omega pc equals to root 2 is being tabulated, in that lateral part, in order to decide its overall stability moving towards its gain margin, what we need to do here, we need to substitute this omega pc as a omega in this magnitude statement. The magnitude statement is like this: the magnitude of g of j omega equals to 10 upon omega into square root of 1 plus omega square into square root of 4 plus omega square. So in this expression, we need to replace this omega with this omega pc, phase crossover frequency, that is nothing but what? Root 2. So the magnitude will become what here? Here I will write, its magnitude will become 10 upon omega equals to what? Root 2. So 10 upon root 2, again square root of 1 plus omega square, right? 1 upon root 2 into square root of, here 1 plus omega square. Omega equals to what? Or root 2. So root 2 square equals to what? 2. So square root of 1 plus 2 equals to 3, right? Similarly, in that magnitude statement, last statement is nothing but what? Or the last term which is present within that magnitude statement is 1 upon square root of 4 plus omega square. So here I will write square root of 4 plus omega equals to how much? Root 2. So root 2 square equals to what? 2. So square root of 4 plus 2, it will become square root of 6, right? So totally it will become 10 upon square root of 2 into square root of 3. So square root of 36, right? So 10 upon square root of 36 equals to what? It is 1.66. 1.66 is nothing but what? The magnitude, right? Gain margin. In order to decide the gain margin in terms of decibel, right? It exactly equals to, as we know, the frequency is reciprocal of time. So 1 upon 1.66, right? Where 1.66 is nothing but what? The magnitude of this open loop transfer function. By replacing this omega with this root 2, that is nothing but what? The phase crossover frequency. So when we divide this desired magnitude at omega equals to root 2, its reciprocal will become what? 1 upon 1.66. So I think it is 0.40 something. And finally, what we need to do, the gain margin in terms of decibel equals to what? Right? This desired value is to be substituted with this logarithmic statement 10 log natural log of this obtained value, that is nothing but what? 0.40. 0.40 is nothing but what? The reciprocal of this magnitude at omega equals to root 2. So it will be minus 4.3 something decibel. Okay friends, so as we know, its gain margin is exactly equals to minus 4.32 something decibel. If the value of this gain margin is negative, so definitely we can say that this is the unstable system, right? So the overall stability of that system, or in order to decide whether this is the stable or unstable system, by the virtue of this gain margin, as its gain margin exhibits the negative value, so definitely we can say that this is the unstable system. So all this procedure we need to follow in order to decide the overall stability of that system with the help of this polar plot. So I just hope you had understand all these things regarding to this polar plot. Thank you.